Okay, this is the fourth lesson. Let me just sharpen this pencil. This is the fourth lesson on prisms, pyramids, cylinders, cones, and spheres. So put your heading, skip a line and put the title. This is cones, and these are the critical concepts. Okay, let's look at one thing at a time here. We want to apply the properties of a right circular cone, including the lateral area equals 1/2 the product of the slant height and the circumference of its base. The volume is 1/3 the product of the area of its base and its altitude. Cones are three-dimensional closed surfaces. In general, the term cone refers to a right circular cone with its end closed to form a circular base surface. A cone is similar to a pyramid, but a cone's base is a circle rather than a polygon. Okay, so let's draw a picture of a cone. We have an apex, right? So that's what the top of a cone looks like, and then to show that it's a circular base, we make the bottom curved, right, like that. And we can also show with a dotted or a dashed line the hidden part behind it. Okay, now the distance down along its lateral edge is S, which is the slant height. Okay, and then we have the line that goes directly to the side of the circle, which is the radius, R, and we have the height, which comes straight down and meets the radius perpendicularly. This is H. So those are basically our values, okay? So let's put S is slant height, R is radius, and H is height. Okay, that's enough for this side. Let's go to the back side now. So we have the volume of a cone can be calculated in the same manner as the volume of a pyramid. Remember, it was 1/3 times the base area times the height. So the volume is 1/3 the product of the base area times the height of the cone. Okay? Where V is volume, B is the base area, which is the area of the base, which is a circle, and H is the height, the distance from the apex straight down to the base, or the altitude. Since the area of a circle is pi r squared, we can plug that in for B, right, because this is the area of the base, so that the formula can be rewritten as V equals 1/3 pi r squared H. So we plugged in pi r squared for B. Okay? Now, let me just take a look at something real quick. Okay, so let's write on the side here, V equals volume, R is radius, H is height. Okay? And let's draw another picture of a cone. Okay? So we have this area on the bottom. Whoops. We have this, which is the area, which is B, which is pi r squared. Right? That's the area of a circle. And then we have that radius, and we have the height. So we don't need the slant height for volume, okay? We need the altitude height, the height straight down, like if you were up on that point and you dropped the weight straight down into the middle of the cone and it hit the middle of the floor. That's the height. Okay? That's it for this side. Let's go to a new sheet. Put your heading. Skip a line. Let's talk about surface area. The surface area of a closed cone is a combination of the lateral area and the area of the base. When cut along the slant side and disassembled, the surface of a cone becomes one circular base, which is the base surface, and a sector of a circle, the lateral surface, as seen below. And we'll see a picture of that in a minute. The length of the arc of the sector is the same as the circumference of the circular base. Okay? Using the fact that the area of a circle is pi r squared and the circumference of a circle is 2 pi r, we can use a proportion. And this is the proportion that we would set up. Okay? We would say the area of the sector divided by the area if the circle was complete equals the length of the sector arc divided by the circumference if the circle was complete. And when you see the picture, you'll see exactly what that means. So when we simplify, we would get area of the sector over pi s squared equals 2 pi r over 2 pi s. When we cross multiply and then divide by 2 pi s, right, we would get the area of the sector equals 2 pi r over 2 pi s times pi s squared, which equals s pi r. Okay? So now that we know the area of the base circle is pi r squared and the area of the sector is s pi r, we can add them up to get the total surface area of a closed right circular cone. Okay? Which is surface area equals s pi r, which is the lateral area, in other words the sector area, and we have pi r squared, which is the circle part area. And here's what I mean by that. Okay, now, if you got confused on this stuff up here, don't even worry about it, because it's not even, it's not necessary to understand this. This is why we get this formula. But if you know this formula, then that's enough. Okay, but you do have to know that s pi r is the lateral area and pi r squared is the circle area. And here's what I mean by that. Let's draw a picture, all right, of a cylinder, right? I mean a cone. Okay. Now, if we spelled that wrong. If we disassemble the cone, this is what we would get. We would have that circular base, right? The circle base. And let's see if I could do a quick demo of what else we would have. Now, this is not going to be easy, but I'm going to give it a shot. Okay. Almost got it. So, here we have a cone, right? Pretend this side was saying shut the way it's supposed to. We have this cone, right? Now this bottom is the circle base. And this surface on the outside, this is the lateral area. Okay, so if I unwrap this cone, you see what we have is a sector, a part of a circle. Okay? We have a piece of a circle. And now this could be bigger or smaller depending on what type of cone we have. Okay? So this is called a sector of a circle. It's a piece of a circle. So our lateral area would look, depending on what type, how big the cone is and things, it's basically a piece of a circle. Okay? This is the lateral area, also called the sector area. Alright, so the area of this is that S pi r part. This is S pi r, where S is this distance here. Okay? And the base, the circle base, is the pi r squared part. And the r is the radius of the little circle. So we need to know the radius of the little circle for this part of the formula and for this part of the formula. Okay? So let's just put again in here. This is our R, this is our H, and this is our S. Okay? And when we disassemble this cone, we get a circular base whose area is pi r squared, and we get a sector of a circle. And the area of this sector of the circle is the slant height times pi times the radius. So when we want to know the total surface area, we add the circle base, which is the pi r squared, plus the sector area, which is S pi r. And that's how you get your total surface area. Okay? Now let's move on. Turn this over. Any surface area question must be read carefully because the surface area formula can change depending on the problem. Remember the cylinder? Sometimes the cylinder can be open, sometimes it's shut. Well, the cone can have a base, and it also could be open and not have a base. Okay? So, it says, will the surface area include the base? If it does, then it's the formula we just talked about. It has a lateral area and a circle base, right? So, we would be talking about the full cone here. We would be talking about that area plus the lateral area. Okay? Sometimes the surface will not include the base. So if it doesn't include the base, remember the base is the circle part. So the pi r squared part, which is the area of the base, we don't have that anymore. All we have is the lateral area. So basically all we have is, we have an open cone, right? So all we care about now is the lateral area. There's no base area. So this is the S pi r. This is the S pi r and pi r squared. Okay? Now let's do some problems. Put your name at the top. Okay. Now, find the volume of this right circular cone to the nearest cubic foot. Let me get out my calculator. V equals 1/3 pi r squared h. Okay? V equals 1/3 pi. Look at this. They gave us the circumference. The circumference is 2 pi r. So 24.6 equals 2 pi r. Divide by 2 pi, and our radius, the 2's and the pi's cancel. Our radius is 24.6 divided by 2 pi. That's our radius that we're going to plug in for this r. So what we have here is 24.6 divided by 2 pi, and that's squared, times h, which is 5. Okay? So what's nice about this is that the 2 pi's are going to cancel out. We have one up here and one down below, so those cancel. Alright? So let's start to simplify this. We have volume equals 1/3 times 24.6 divided by 2 is 12.3. So it's times 12.3 squared times 5. Alright? So the volume equals, watch how I put my 1/3 in parentheses, 1/3 times, in parentheses, 12.3, close the parentheses, squared, times 5. And I get 252.15. I got to round to the nearest cubic foot, so the volume is approximately 252 feet cubed. Okay, don't forget your unit. Next problem. A cylinder and a cone each have a radius of 3 centimeters. So this r is 3, and this r is 3, and a height of 8. So this h is 8, and this h is 8. What is the ratio of the volume of the cone to the volume of the cylinder? So that means we got to do volume of cone over or over volume of, so okay, so it says volume of cone, so that goes on top, to the volume of the cylinder, so that goes on bottom. That's what we need to figure out. So first let's find the volume of the cone. 1/3 pi r squared h. Volume equals 1/3 pi 3 squared times 8. Volume equals, let's see, 3 squared is 9. 9 times 8 is 72. And 72 divided by 3 is 24. So this volume is 24 pi. Alright, I'm going to leave pi in the formula for now. The volume of a cylinder is just pi r squared h. You see the difference? It's very close. This one is 1/3. That's the only difference. So volume equals pi 3 squared times 8. So this volume is 72. Let me just double check that. 3 squared times 8 is 72 pi. Okay? So the volume of the cone over the volume of the cylinder, we have 24 pi over 72 pi, and now we just reduce that. The pi's cancel. So we have 24 over 72. We can divide the top and bottom, let's see. We can divide the top and bottom, I think, by 12. Even more, maybe 24. Yes, we can divide the top and bottom by 24, and we get 1/3. That's it. Okay? You could also write that as like this, 1/3. Oh, we should put a we should put it like this with a label under here. 1 centimeter cubed to 3 centimeters cubed, or 1 centimeter cubed colon 3 centimeters cubed. Because we can write a ratio either one of those ways. Now we have a lateral surface area problem of a right circular cone. Alright, it says it can also be represented by this equation, which we didn't talk about, so you don't have to know that equation. But they're giving it to us. So r is the radius of the base, h is the height of the cone. If the lateral surface area is 236.64 and its radius is 4.75, so this equals pi times 4.75, I'm just plugging it into this formula, square root of 4.75 squared plus h squared. Okay? We're trying to find the height to the nearest hundredth of a centimeter. So first let's divide both sides by pi times 4.75. Okay, that cancels with that cancels with that, and we get 236.64 divided by 4.75. Actually, we got to divide it by 4.75 times pi, so 236.64 divided by 4.75 pi. Alright, so let's go to 4 places after the decimal. That would be 15.8579. And that's approximately equal to the square root. Now we have 4.75 squared, 22.5625 plus h squared. Okay? Now we're going to square both sides, because that will get rid of that. So 15.8579 squared is 251.4730. Right, if I round to the 4th place, and that's approximately 22.5625 plus h squared. So subtract 22.5625 from both sides. $251.4730 minus 22.5625. I got 228.9105 equals h squared. Do the square root of both sides. So now h is the square root of 228.9105. So OH is approximately, H is approximately, and we got to round to the nearest hundredth, so 15.13. And that's centimeters. Okay. And that problem is done. See, if you go to at least the 4 places after the decimal, you will never have any rounding errors in this class, okay? So just always go to 4 places after the decimal. Alright? Let me just check something real quick. I just want to make sure 236.64 divided by 4.75 pi squared then subtract 22.5625. So square root shift answer. See, 15.13. So that was done exact, and I still got almost the same exact thing. Okay, next one. In the chart below, the dimensions of a cylinder and a cone are doubled and tripled. Find the volume of all 3 cylinders and all 3 cones. When finished, state a hypothesis as to what happens to the volume of solids when the sides are doubled and tripled. Huh. Okay. Alright, so here's what we're going to do. First we're going to do the cylinder for when R equals 4 and H equals 7. Volume equals 1/3. Nope. Volume equals pi R squared H. Volume equals pi times 4 squared times 7. Volume equals, I'm going to leave everything in terms of pi, so 112 pi. And that's, there's no label, alright, so we could put units cubed, but alright, we might as well do that. Units cubed. So that was the first part for the cylinder. Now our radius is doubled. It's 8 and our height is doubled to 14, so we want to see what happens now. Volume equals pi R squared H. Volume equals pi 8 squared times 14. Volume equals 8 squared times 14. 896 pi units cubed. Okay, and we have one more. This is when it's tripled. So this time R is 12 and H is 21. So volume equals pi R squared H. Volume equals pi times 12 squared times 21. So the volume is 12 squared times 21. 3024 pi units cubed. Okay? Now let's do the cone. So first we'll do when R is 4 and H is 7. Volume equals 1/3 pi R squared H. Volume equals 1/3 pi times 4 squared times 7. Volume equals 1/3 times 4 squared times 7. Alright, let's write it as a fraction instead, because I don't feel like doing decimals. 4 squared times 7 is 112. So it's 112 pi over 3. 112 pi over 3 units cubed. Whoop. Next one, R is 8, H is 14, volume is 1/3 pi R squared H, volume is 1/3 pi times 8 squared times 14. Volume is, let's see if this one works out exact, otherwise we'll just do a fraction again. 8 squared times 14 divided by 3. Nope. So we'll just leave it as a fraction. 8 squared times 14 is 896 pi all over 3 units cubed. One more to go. This time the R is 12 and the H is 21. 1/3 pi R squared H, 1/3 pi times 12 squared times 21. Let's see what happens with this one. 12 squared times 21 divided by 3. This one actually comes out even. But I'm going to still leave it as a fraction because it's going to be easier to see the difference. So 12 squared times 21 is 3024 pi over 3 units cubed. Okay. So, let's see what happened here. Look at what happens to the volume when you double the radius and the height. It went from 112 pi to 896 pi. So what did you multiply the volume by when you doubled the height? Well, let's see. 896 pi divided by 112 pi. 78.9 times as big. So what about 112 pi squared? It's 123,804. What's 896 pi? Nope, it's not that. 112. Oh, okay, let me see. I think I forgot the parentheses. Yep, that's probably what happened. 896 pi in parentheses divided by 112 pi. 8. So, when we double the radius and height, the volume is multiplied by 8. And let's see if that's true for the cone too, which it should be. Let's take, now watch how I put this in here. I have two parentheses, 896 pi, close that parenthesis, divided by 3, now close the whole thing in. So that's my first big fraction here. And I'm dividing that by 112 pi, close that first parenthesis, divided by 3, close the next parenthesis. So I'm taking this fraction and I'm dividing it by this fraction to see how many times this goes into that, or how many times I have to multiply this to get that. And we're going to get 8. See? So when we double the radius and height, the volume, let's put it at the beginning. For a cylinder and cone, comma, when we double the radius and height, the volume is multiplied by 8, comma, and when we triple the radius and height, the volume is multiplied by, let's see, 3024 pi in parentheses divided by 112 pi in parentheses. 27. We multiply by 27. Let's check that on the cone. So 3024 pi divided by 3 divided by 112 pi divided by 3. 27. Okay, so that's the answer. If you double the radius and the height of a cylinder or a cone, the volume goes up by a factor of 8. If you triple it, the volume goes up by a factor of 27. Okay. Sharpen my pencil. Okay. Put your name. These are the last two. In the diagram below, a right circular cone has a diameter of 8 inches, so the diameter equals 8. The radius equals the diameter divided by 2. The radius is 8 over 2. The radius is 4 inches, right? Because when we're working with cones, we care about the radius, not the diameter. So before I even look at the question any further, I just found the radius. And a height of 12. What's the volume to the nearest cubic inch? Volume equals 1/3 pi r squared h. Volume equals 1/3 pi times 4 squared times 12. We need this to the nearest cubic inch. 1/3 times pi times 4 squared times 12. 201. That's it, 201 inches cubed. A right circular cone has a base with a radius of 15 centimeters and a vertical height of 20 centimeters and a slant height of 25 centimeters. Find in terms of pi the number of square centimeters in the lateral area of the cone. Remember, the lateral area is just S pi r. So the lateral area is 25 times pi times 15. It says in terms of pi, so we leave pi in the problem. So the lateral area is 25 times 15, 375 pi, and that's centimeters squared. Okay? Now let's just take a minute to we had 2 pages of problems, so this is 1 of 2 and 2 of 2. And we had 2 pages of notes. So 1 of 2, 2 of 2. Okay? And that is the end of the lesson on cones.